Okay, we will get started. Thank you for joining us today for our bi-monthly webinars. This one is on Chalk River Laboratories Stored Liquid Waste Project. First, CNL respectfully acknowledges that the Chalk River Laboratory site is located on the unceded and unsurrendered territory of the Algonquin Anishinaabe Nation. We recognize and appreciate that their historical connection to this land, and as the customary keepers and defenders of the Ottawa River watershed and its tributaries. We also recognize and appreciate the contributions that all First Nations, Métis, and Inuit peoples have made and continue to make in shaping this land we now know as Canada. We acknowledge, respect, and seek to better understand the unique Indigenous history, rights, and title on the lands where we work. Before we kick off today's presentations, we have a few logistical things to note. First, there's simultaneous interpretation. You can access the session in French and English through the globe icon on the bottom right on the bar on Zoom. Select the language you'd like to hear. Today's session is planned for about 45 minutes. We anticipate the presentation will take around 20 to 25, and the rest will be for questions. We do have a second webinar after this, so we try to close off before the hour mark so we can switch over. The way you can ask questions is the Q&A icon. So click that and you could submit questions in writing at any point during the presentation, and we'll respond to all the questions following the presentation during the Q&A component. If we do not get to your question, or it's a very technical question and we need to look for further explanation, we do send an email with write-up responses later on with a link, because we do post these on YouTube. If you experience any technical questions or technical issues, sorry, we do have our team in the background that can help you out. So email ermstakeholder@cnl.ca, and we'll be watching the inbox and we'll try to get you sorted out. Also, we're looking to evaluate our webinars more in depth. So following the webinar, you will receive an email with a link to complete a short 10-question survey. We'd really appreciate it if you take the time to share your thoughts on our webinars. During today's webinar, we'll be hearing from Daniel Arnold. Leading today's presentation, Daniel is a project manager here at Chalk River Laboratories Reactor Decommissioning and Program Execution Group. He has been with CNL for nearly 10 years, and together with his team is currently overseeing the safe decommissioning of multiple CRL projects. So after Daniel is done, we will then open the floor for Q&A. Without further ado, pass things over to Daniel. Over to you.
Thank you very much, Mike. I'm very happy and very proud to be talking about this specific project today, our Stored Liquid Waste project. It's one that's near and dear to my heart for a couple different reasons. I think we all have someone who's been impacted by cancer and has benefited from radiation treatments. The waste I'm going to talk to you about today in this project is important to reduce the liabilities and effectively manage that waste that was created by generating cobalt-60, which is used for those applications. So it's quite near and dear to my heart. I'm very proud of the work we accomplished recently. So I'm excited to take you through this project and its recent accomplishments. I'll talk to you about our FD mission, the Stored Liquid Waste project, and some next steps we have going on. And I'll be very happy to answer any questions you have. So our mission, I work in facilities decommissioning and environmental remediation. Our mission is simple and purposeful. Our mission is to restore and protect the environment through reducing Canada's nuclear legacy liabilities. Me, myself, and our team, we're based in the Chalk River facility, and this is where the brunt of our work happens, although we do have multiple locations for CNL across Canada. What this work actually looks like is a couple different things. First, we start with understanding the facilities, the waste associated, and the liabilities there. We do this by scoping and surveillance, by taking radiation measurements, or by investigating any more traditional industrial hazards and understanding the state. Once we do that, after we've received the facilities into our care, we perform storage surveillance, which means we maintain them in a safe state. We prepare surveillance plans and maintenance plans, and we perform preventative or corrective maintenance to bring them into good standing. Perform housekeeping activities, keep them clean, tidy, and safe for our workers. We maintain operational records, and we really dive into how we're going to get this facility into a safe shutdown state. Sometimes that means upgrading facilities to get ready for decommissioning activities. Other times it means just safekeeping. We also do in-depth planning. That means taking characterization samples to determine our waste paths, preparing necessary documentation for our regulator or for our own project plans, assessing the risk and formulating our strategies, and obtaining the necessary approvals, both regulatory and internal, before we proceed with physical decommissioning. Everyone's most excited about the physical work, and this is what it looks like. It's quite large scale at times. It can also be quite delicate and detailed. It means removing traditional risks and liabilities such as asbestos, lead paint, mercury in gauges and instrumentation, industrial or designate substances from the buildings before demolition. It also means removing nuclear waste or nuclear liabilities and hazards. To date, this means quite a large skyline change to the Chalk River campus, with 121 buildings being demolished, over 250,000 kilograms of asbestos being removed, 3 million kilograms of low-level radioactive waste, and 20 million kilograms of decommissioning debris. That's the large-scale end of the decommissioning project outcome, which is always exciting to see. It means that space that's occupied at Chalk River can be redeployed for new builds to sustain our other missions. Now, where the Store Liquid Waste project comes in is a little bit unique, and I'm excited to talk about it. I'll tell you our current state and where our waste came from, and then we'll go through a little bit about our recent achievements. So, in 1940s, the Chalk River site was born with the creation of NRX. Shortly after that, in the 1950s, cobalt-60, a radioactive isotope used in medical sterilization, cancer treatments, and industrial radiography, came into production and ramped up. This was produced in both the NRX and NRU reactors at Chalk River, as well through the 60s and 80s. Canada's CANDU reactors, which are pressurized heavy water reactors, began to use large-scale cobalt-60 production as well. Through this, we expanded our role to the top supplier of medical-grade cobalt-60 in the world. And to date, it's something we maintain as well. So that's where our waste came from. Through the 90s and 2000s, Canada still supplied cobalt-60 to more than 40 countries, and is widely used not only for cancer treatments now, but also sterilization of medical equipment, to irradiate food to get it ready for longer shelf life and shipping, and as well as other industrial applications. And to date, Canadian cobalt-60 sterilizes over 40% of the world's single-use medical devices, remains crucial in cancer treatment, infection prevention, especially during recent pandemics such as COVID-19. CNL itself produced our last batch of cobalt-60 in 2019, which was the last generation of the waste I'm about to talk to you about. And this is what it looked like. These are what we call wafers. They contained cobalt targets that were put into the reactor to be exposed to high fields. That creates the cobalt-60 we're looking for. These wafers are then removed from the reactor and brought into a hot cell facility at Chalk River Labs. That's where these photos were taken. To get the wafers out of this aluminum mold, they're dissolved in a solution, and that solution is then transported into storage tanks. The wafers were then taken and transferred through supply chain to get ready for medical applications. So that waste has been at CNL being stored in tanks at various locations since 2019. And that's where the start of the Stored Liquid Waste project began. We have a few key objectives. The first and foremost is to reduce the environmental liability. This waste is highly hazardous, both from chemical and radiological perspectives, large in volume and complex to deal with. So we want to remove that liability from the environment as quickly and safely and effectively as possible. To do that, we want to retrieve the contents of the tank, both its liquid, sludge, and particulate, and make that waste safe for long-term storage before it can be disposed of. At the same time, these tanks have been in use since our early days at Chalk River in the 40s and 50s. The tanks are nearing the end of their life, and so are the facilities that hold them as well. So as we're dealing with the tank contents and making that waste safe for storage, we're also preparing the facilities for decommissioning as well, because they're at the end of their life as well. This is where this work actually takes place. This is a lovely Google Maps photo of our Chalk River campus. You can see Tim Hortons for reference if you've ever been to site, which is a beautiful landmark. And it's important to note because this is a very large campus with an ongoing S&T mission and several other capital and decommissioning projects ongoing as well. So with over 16 tanks spread across the site in two large geographical locations, it makes mobilization and planning to deal with this waste quite complex and takes some additional stakeholders into engagement. We have 5 source waste types and over 200,000 liters of stored liquid waste, which was most recently characterized in 2018. These are some photos of the facilities that you can that store the waste currently. The photo on your left, there is several tanks buried underground, and these are of the waste is of a nature that is capable to be shipped and transported, but there's not a facility at Chalk River Labs with CNL or within supply chain that can currently accept this waste to be processed. The goal of processing this waste from a liquid and turning into a solid is to make it safe for long-term storage. We can do that through bitumification, cementation, turning it to glass, a few other different options. But this specific location on the left, there's no facility capable of doing it in its current state. So we've engaged supply chain to develop an in situ processing skid to reduce the liabilities and the hazards associated. So someone within supply chain or another facility at Chalk River may receive this waste and make it safe for storage. The photo on the right is a larger area with several buildings that contain stored liquid waste tanks. This is the site of our most recent liquid retrieval campaign, uh, which was executed from January to March in the field. Tanks are situated under the lean-to structure in the background of the photo, and those yellow shipping totes are what we use to safely transport the waste. This is a small snapshot of what our waste and the different contents, different colors note the different types of waste and the rough volumes. Some of our tanks are as large as 40,000 liters. And what's interesting is that means you may have stratification layers, you may have large amounts of sediment or sludge in the tanks, which all require some in-depth planning. The high level and the point of this slide is to signify that it's not a one arrow solution. It's not as simple as developing one process to retrieve and process, make safe for storage, because we have a large diversity of waste types, waste sources, um, chemical hazards, and radiological hazards that we'll have to mitigate as we perform this work. This is a handy video of inside one of our tanks. You can see they're stainless steel walled. Um, this one has been emptied recently. You can see the general state. They're intact, managed, maintained. We do camera inspections and characterization. But this is the bottom of the tank and what we call a sludge layer. It doesn't look like a sludge that I think of intuitively, more of like a sediment or a concrete, but it's a rather unique hazard to have because this waste was sent from an operating facility through either totes or pipes directly to this tank. and this debris was in that liquid and settled to the bottom. You can imagine a complex array of radionuclides and different chemicals, and this is something we're developing a strategy to go in and retrieve this specific waste before we prepare the rest of the facility for safe decommission. You can imagine some of these tanks having different layers with sludge, sediment, and liquid, and unique approaches have to be developed and deployed to remove that in a certain way so that we can get the liquid for processing, the sludge for processing, then remove any sediment as well for long-term storage. So for our recent project accomplishments, it really ramped up in the last fiscal year, which just starts on April 1st and March 31st. We underwent a significant campaign to remove the free liquid from tank 40B, which is a pivotal step in the project. It's quite important because liquid waste is complex by nature, and this level of an endeavor hasn't been undertaken in several decades. However, the team formed a very collaborative planning phase where we engaged safety stakeholders, radiation protection, engaged various regulators as well, and supply chain in order to remove this liquid starting in January. And it means we wrapped up retrievals at the start of March. This required the creation and deployment of a custom dip leg to enter the tank, as well as a pumping system to remove the liquid through uh, housing and put it into the tank to a certain level. The tanks were then transported through to a supply chain support where the contents is then processed, solidified, and returned to Chalk River for long-term storage. In its total, we've removed 40,000 liters of this liquid waste, which came from cobalt processing in CNL's earlier history. What's fantastic to note here is this work was planned in very collaborative but very short order, really ramping up in September, and we received our last license in December in order to proceed with this work. And then the team executed in January, wrapping up in March with support from all across site. It's a very good news story. We maintained safety excellence. There was no very large issues despite nasty weather, and as you can imagine, in the Ottawa Valley in winter. And the work was done successfully to remove 40,000 liters of high hazard liability waste from CNL. We have a couple photos here of what this work actually looked like. On the far left, you can see an operator and a radiation protection staff connecting the pumping system to the dip leg in tank 40B. You can see the lovely snow, which we experience here, adding some complications, but the team was able to persevere and do this work near daily throughout this time. They would connect the hose to the dip leg in the tank and utilize a peristolic pump with a custom-made control panel to automatically remove the liquid from the tank, pass it through the pump, and then into the shipping tote. The shipping tote and the pumping system would automatically give a warning when it reached nearing capacity and would turn itself off when we reached the desired fill height of the tote. This meant that although staff were required to make the connections, supervise and witness and facilitate the pumping process, when it was actually operating, they could remove themselves from the direct working area and in fields associated. The center photo is the connection to the shipping tote itself, and you can see staff making the connection and checking dose rates. And the photo on the far right is a different view of the location we showed you earlier. You can see our bank of shipping totes ready to receive liquid and a trailer in the background, which was heated in order to transport this waste to supply chain for processing. This work, again, occurred in a relatively small location at Chalk River, but required support and logistics across the site to pull this off. And it's a very good success story of what can happen when we plan work collaboratively across the company and then deploy it successfully. Going forward, this is a very good news story and a little bit of a pivot in our mentality on this project. In 2020, a year after we stopped cobalt-60 production at Chalk River, we created an original project strategy pre-COVID and some other complications that threw wrench into a lot of projects. But it meant that we proceeded from our lowest hazard waste to our highest hazard waste, and we were embedded with the mindset that we would process this waste internally with facilities at Chalk River um, to solidify this waste and make it safe for long-term storage. Some risks were realized and we were required to pivot to supply chain, which is what we did this past year. And what that means is we can look at this strategy with a new lens. So by utilizing supply chain, we have completely emptied the liquid from building 224. So that facility, we can now focus our efforts on removing the sludge and sediment and getting that building ready for active decommissioning. It also means for our other tanks, we can look at removing liquid at a faster pace than we originally anticipated, which is important because although these facilities are maintained safely now, they do pose an environmental risk of possible leaks or failures and things along those lines. So in building 222, there's 132,000 liters of liquid waste, which we're could and we aspire to mobilize to retrieve that liquid in 2026. By, again, utilizing supply chain, we can also get ready to remove an additional 50,000 liters of waste from building 538. And in the meantime, with those higher hazard tanks or higher complexity ones, which we can't process quite yet, we can partner with supply chain to expedite the construction of that in situ processing facility and then get ready for utilize supply chain to do the final processing of that waste as well. So by partnering with the broader nuclear industry, we can advance our schedules to more aggressively or more purposefully remove the nuclear liabilities from the environment in Chalk River. And this allows us not only to deal with the stored liquid waste within our portfolio now, but also get these facilities ready for safe decommissioning faster than originally planned as well. That sums up what I wanted to talk to you about today. We introduced you or recapped, if you're familiar already, with our FD mission, some of our broader scope. We talked about the new scope of the stored liquid waste project, where our waste came from, the recent work we did with some liquid retrievals, and then the good news and learning lessons about being agile with our project management style and pivoting to supply chain, and then the benefits that causes for or opportunities that realizes for our future scope of work as well. So with that, I'm very excited to hear some questions.
Okay, awesome. Thank you, Daniel, for a great presentation. Lots of info, great story, how we're removing the liability. So let's get to some questions. So again, you can use the Q&A function to type in some questions, and we'll get to them. Okay, question number one. How does the Stored Liquid Waste project contribute to addressing environmental risk at CRL and set a precedent for future projects?
It's a good question, Mike. Thank you. Our tanks were, again, installed in the early days of Chalk River, many decades ago when practices were a little bit different. They've since then been used through they extended their life for different processes to hold different waste before it was ready for processing, including cobalt processing waste. The facilities they're in have also been, erected at that same time and gone through the same life. All that to say, they're at the end of their life, and if we don't effectively remove the liabilities from the facility and plan and purposefully move with their decommissioning, it poses a risk for release to the environment, which is why this project is so important to remove the liquid from the tanks, make that safe for storage before disposal, and then that enables us to do the same with the facilities as well.
Okay, thank you. You mentioned winter. We always have to battle winter here. We actually got a winter this year. How does the team overcome the challenges associated with winter and other adverse weather operations while waste removal operations were underway?
It's a good question, and I have an unfortunate association now that if I ask people to go on a walk down, they expect it to be minus 20 or minus 30 and sleet sideways. But that's the nature of work, and it keeps you on point, on schedule. We overcame these challenges more seriously with a couple different measures. One is the proper PPE and C for the team. Two is a temporary enclosure which we heated to keep workers comfortable and safe to operate. And another one is also to procure services and items in excess, just in case of transport risks in terms of equipment breakdown and things like that. A good example is we utilized heated trailers for transport. Uh, we procured those in excess, so we always had one on standby. So there was always a heated trailer being loaded, there was always one on standby, and there's always one in transport. And what that meant is that if the trailer had any problems due to weather conditions, we had another one ready to step in, so we didn't have to slow down operations. Or if there's a mechanical failure on the heaters for the trailers or a tire blew, anything of the sort, we had another one ready to go. So that was a risk that was present throughout the project, one that was realized. We had, heaters fail and we had tire problems and things like that, but we had additional supply of services and materials to step in.
Okay, thank you. All right, just looking at our Q&A here. Were there any collaborative efforts involved in this project from other CNL departments?
Yeah, of course. So there was our usual friends in our safety programs and radiation protection, from industrial hygienists to occupational safety and health professionals to radiation protection and health physicists. There was also safeguard experts, transportation of dangerous goods experts, logistics experts, heavy equipment operators, operations staff, technologists, maintenance team. There was a small fleet or army of people that we pulled matrix support from across the company to help. I'd say also of highlight, I report through the decommissioning mission, as does my team. However, these facilities uh, are owned and operated and belong to our waste management department. So although an internal nuance, this was a unique instance where we could take decommissioning expertise and project execution and then partner with a waste operations team to perform this work within their facility. So we're helping them prepare the facility for safe shutdown and get it ready for SWS and decommissioning. Um, that's a bit of a new scope for us, and it's a new scope for waste, but it worked very well where we could, utilize their operating expertise from their own facilities in order to do this decommissioning like work. So it worked very well. Thank you.
Okay, thanks for that. Um, where will this waste be stored once removed?
Good question. So this waste was removed and is being processed now. It's being solidified and cemented. It will be placed into 55-gallon drums, which is lined and standard use for storage of this type of waste. It will be returned to Chalk River Labs and will be stored in our waste management areas until there's a final disposal location, which is determined by the Nuclear Waste Management Organization and some of CNL's other projects as well.
All right, thank you. What type of, did you do any specific custom tooling for this project?
Oh, we did. That was another collaboration with our fluids engineering team in our science and technology mission. They developed a custom dip leg to enter the tank so that we could remove the free liquid and not any of the sediment or sludge within the tank, as well as a heat trace for that line, because of course we wanted to do this in winter. And then they also designed and fabricated and commissioned the pumping apparatus as well. So that used a peristaltic pump with a custom control panel to turn on and turn off the pump once the totes are full. So it shows the power or the some of the benefits and opportunities of working at CNL, where we have resources who can invent new tooling, fabricate it, commission it, and then we have the operations excellence to deploy it as well. So it's a good success story there.
Okay, great. Thank you. Um, so just a reminder to use the Q&A function. I do see someone did put their hand up, but in the style of this webinar, we only have the type Q&A function to use. So we will keep going here. We still got some time, so just wait for a few more questions to come in. What was your biggest challenge this year?
Um, I'd say the weather, a stereotypical one, but it is quite true. When you're trying to line up, um, dozens and dozens and dozens of staff, as well as transportation and logistics with regulators and supply chain facilities, you want some predictability in your schedule. Unfortunately, weather breaks equipment, it slows down road conditions, it makes the work area unsafe due to slipping if we have freezing rain, um, and it can definitely cause some hiccups. So that was our largest challenge. It required daily, if not hourly, updates and mitigations and changes in approach. But by procuring extra trailers, making sure staff spend the time to clean the work area before they proceed with liquor retrievals, with snow removal and salt and things like that. Um, it all ensured we were able to do this work safely, but was definitely a challenge and ended with some extra work there as well.
Okay, thank you for that. You mentioned collaborative efforts. How did the collaboration between departments contribute to the planning phase of your most recent efforts?
It's a good question. So again, this is new of a kind scope for our decommissioning mission. So we were able to utilize fluid engineering experts from our science and technology group to provide us the idea for the dip leg as well as the pumping system. And that allowed us to, once we had an idea of physically how we do this work, to collaborate with our waste management team to gain their expertise in their facilities and how they would operate this equipment to remove the liquid. As well, we had to collaborate then with our procurement and transportation teams and radiation protection and regulatory and compliance programs to see how we could get this through to supply chain for processing. Um, that all happens in our planning phase, where we have to take a conceptual idea, get it through the engineering might, and then through our integrated work control process, and get it ready for field deployment. So it's can't understate quite enough how many people and how many conversations and how many walkdowns we need to have in order to effectively plan and safely execute work like this.
Okay, thank you. Will CNL's NSDF facility be used to help store these treated liquid wastes after they are solidified?
That's a good question. There's a specific waste acceptance criteria for the near surface disposal facility, which is to be built at Chalk River. Um, some of our waste may be a candidate for that, but we'd have to evaluate it compared to the waste acceptance criteria or WAC. Some of our waste is low level through PBE generation and things like that. Others is intermediate level or different. So then they would not be clear applicants or our candidates for that location.
Okay, thank you. So that is it for questions. We'll wait a few more minutes to see if any more come in. But just a reminder that if your question comes in as we're leaving, we still see it and we'll throw that into our responses, our follow-up responses. So to avoid awkward silence, I will go through the my ending notes. Thank you for attending the webinar today. I'd like to encourage everyone to please take the time to complete our follow-up survey that we'll be sending out shortly after the webinar. Um, once we get the links to the recording, we post them on YouTube, and then we will put the links into our response email with the answers to the questions we don't get to. Please feel free to just distribute that to anyone that might be interested. And please remember, if you do have any questions that you think of later on, you could always get in touch with us at ermstakeholder@cnl.ca. One final check, and no more questions. So that will be the end of our webinar today. Thank you so much, Daniel, for taking the time to do this. Great presentation, great answers to the questions. And shout out to all our team helping in the background. I know our coworker Jason is currently in Japan, which is it's almost midnight there. I don't think he'd be watching. He's on vacation. But yeah, thank you everyone for tuning in, and we will see you next time. Oh, and a reminder that we do have a webinar next time, or in the next hour, on our WR1 project out at Whiteshell Labs in Manitoba. So tune into that. Okay, thank you, everybody. Have a good day.
Thank you all very much. Bye now.